Hi, everyone, and thank you for joining today's webinar, Lessons Learned from Building a 40,000 Core Grid for a Global Investment Bank. I am Anya Butov, and I'm joined today by our co-founder and CEO, Kirat Singh. So today we're going to go over just a few minutes of background on Beacon, and then we will show you three pretty typical client scenarios for how our clients are using Beacon. And before we start, just on behalf of Kirat and myself and everyone at Beacon, we just want to say that we hope everybody is staying healthy and safe, and we really appreciate you all taking the time to join us today and learn a little bit more about us. So a bit of background on Beacon. Beacon is a cloud-native application development platform that's optimized for capital markets. So if you go left to right on this slide here that you're seeing on your screen, the Beacon solution includes a suite of applications for business users, and it also includes developer tools and infrastructure tools. So our business applications are for trading, risk, pre-trade analytics, middle office, a bunch of different business use cases. And what makes Beacon really unique is that our solution also comes with a development platform that includes the source code for everything, all of our applications, all of our financial models. We're quite unique in this respect. And by giving our clients the same developer tools that we use and access to the same source code that we use, we really empower them to make the platform their own and to extend it. Last but not least, Beacon comes with infrastructure services, and we make it very easy for clients to leverage the cloud. So a couple of weeks ago, we did a webinar that showed a bunch of our trading and risk applications. For today, we're going to focus much more on the development platform and on the cloud infrastructure tools. And the idea really is that with Beacon, you should be able to come up with an idea, research it, backtest it, prototype it, and deploy it to your users all within one platform. And what we hear from our clients is that once they bring Beacon into their organization, they start to see a lot of benefits in collaboration and productivity. And by using Beacon as their gateway to the cloud, they save themselves a lot of time and cost and efforts and heartache, which Kirat will talk about in just a minute. So with that context in mind, I'll pass it to Kirat to share a bit of the history behind Beacon, and then we will move into the demo. Kirat, go ahead.
Great, thanks very much, Anya. And folks, really appreciate you joining us on this today. And I just wanted to echo Anya's comments as well. I know it's a challenging times, and I think we're all very lucky we can work from home and dial in these webinars. So thank you again for taking the time. So just a bit of background on why we started Beacon. So in late 90s, Mark Higgins and I who's my co-founder, were both at Goldman, and we started on the currencies and commodities desk. And as you folks probably remember, in the late 90s, everyone had high-powered desktops, which were probably 2 gigabytes of RAM and Sun workstations for everything else. And I actually used to sit in the office where Fisher Black used to sit like probably a decade ago. So, big shoes to fill. But, really sort of exciting time there. People were just starting to add like things like wings to volatilities, and we were building pricing tools for the desk. I was lucky enough to be part of one of the core developers of SecDB as it was expanding. And we built, for example, the first compute grid there. So we brought in Linux. We started using Linux to actually network computers because, basically we were trying to run large-scale risk reports and intraday risk that didn't work at all on one computer, even if you bought like a 16-core Sunbox. And after that, did that for about 10 years or so. And, I was really lucky to be part of the team that extended SecDB to interest rates and equities and then credit. So a very unique experience for us. Went to JP Morgan and started this project called Athena with Mark Higgins, where we built an internal risk and trading system for FX and commodities again. And, those businesses grew a whole bunch during those years. FX options doubled in size. Commodities hit like $1 billion. It's part of like the Bear and RBS acquisitions that JP did as well. So again, really exciting to enable those businesses. I went to Bank of America in 2010 and started the system called Quartz there. And Bank of America, big bank, lots of mergers over time, 150 upstream trading systems. So we built one system where we could put all the data of our trades, positions, market data, integrate all the analytics, and we managed to use that to solve regulatory issues, end of day risk for the entire bank, credit risk for the entire bank. And my team when we started there was 2 people, and when I left, there were 5,000 people across Bank of America using the system that we built, which was it was great. And we did a lot of infrastructure build there too. We ended up building compute grids again. As you can imagine, solving counterparty credit risk for a big bank, you need lots of compute. So we had something like a 40,000 core compute grid. And really interesting challenges. We built our own databases there as well. And 2014, we started Beacon because our view really was that there's no vendor system out there that's a good fit because they're all black boxes, really good at what they do, but often you want to go and customize things, change the models, plug in new data, build your own applications. And for that, you have to figure out what infrastructure do I need to deploy? What stack do I need to build apps? How do I put all this together? And then more importantly, how do I deploy it to my users and scale it globally across different regions? And we think that with software-defined infrastructure in the cloud providers, Amazon, Azure, et cetera, the right opportunity is to have an abstraction that empowers developers and quants, and of course front office folks as well, to leverage this infrastructure safely and without having to be an expert in every little bit of it. I think for us it's important to build tools to make things. And I tell my kids when they ask me what I do, I was I write programs to make hard things easy. Sometimes we succeed. So back to you, Anya. Oh yeah, thank you. Sorry, I can't click that link. And how does Beacon actually integrate into folks' existing systems? Because our clients are big banks and asset managers and insurance companies. They have lots of existing infrastructure. We don't think Beacon is a big bang approach. We've tried very hard, and including places we've been before and our clients now, to start with a small organic approach where you can start using Beacon for the things that are pain points for you. And the way we think about Beacon really is it's a container, it's a platform. So whether you have your trade sitting in some vendor TRMS or some OMS or some internal trading risk management system, you build pipes once into Beacon. And often folks end up with multiple internal TRMSs and multiple internal vendor systems. Very hard to get a clear picture across all of these. And in Beacon, what we've done is we've built this cross-asset risk trading deal model and also market data. So you have all these components available to you. And we always tell people is, build APIs and platforms rather than systems and applications, because then it's much easier to integrate them together. You can then put quant models together. You can build end user apps. You can manage all your IT infrastructure. And then, of course, we have lots of external integrations, Excel, external apps, web apps, what have you. Back to Anya for the scenarios that we're going to talk through.
Thank you, Kirat. So what we're hoping to show you today is really how all of these components fit together: the software-defined infrastructure, the developer tools, and the end-user business applications. So we'll review 3 pretty typical scenarios. 1, running some scenario analysis at scale. 2, putting on more of a CTO hat. How does an organization enable cloud migration using Beacon? And the 3rd scenario will be about how Beacon really can connect quants and business users together. So for the first scenario, let's imagine I am the head of a trading desk and I have a cross-asset portfolio. I need to understand how it will perform under different scenarios. So I've asked Kirat to help me out with this and show me how Beacon can help me make some trading decisions. So I'll turn the screen over to Kirat to kick off the demo with this scenario.
Great, thanks, Anya. So I just shared my screen here. So as you can see, when you log into Beacon, it basically looks like a web app. You log in through Chrome, but it's really a portal into all the applications and data and infrastructure that you have managed on AWS or even Azure. So in this case, these are the applications we have set up in our environment. A lot of these are available to our clients, and of course, they can write their own. So I got to move these webinar controls out of the way so you can see what I'm doing. So in this case, like Anya and Anya is, talking to me about a scenario she wants to run, like maybe interesting market conditions now. You have a whole bunch of risk, and you're looking at aggregated risk across all your businesses. And, these could be books, trades that you have in a trade blotter, or, aggregated up through some portfolio. So you can see here, I have one of our applications is a trade blotter. It keeps track of all positions and quantities, double entry bookkeeping, all the life cycle events, etc. And often I can run reports from these things, and those are typically about intraday or end of day risk management, and they don't essentially give me a good picture of what's going to happen, like a couple of years down the road, or what my cash and liquidity issues are. As you can see with Beacon, and so here, for example, is a quote tool which has similar positions to the ones that I just talked about, an interest rate swap or cross-currency basis swap. It automatically knows what market data to do. So this is something you might use for intraday risk management or pre-trade risk. But I want to go a little bit deeper here. So let me do that. Beacon comes with a built-in developer environment. So it's, Python, C++, JavaScript. We also support R, and of course you can run other languages as well. There's also like a VS Code version of this, which I will pop out in a second, but I'm not I like to use the old one for a bit. So in this case, I just set up like this little sample portfolio, and I can say maybe my high level view of the risk that I had is a 10-year swap, some interest rate swaption, a bunch of other positions. And what I really want to do is evolve this forward. This is like a 4-year time horizon, monthly time steps, cross-asset portfolio. So I'm just going to F9 this actually while I'm talking. And what I want to do is, if I'm evolving this forward in time, Beacon has a simulation model that will go and take all the market parameters, figure out the correlation between them, evolve them forward in time, and then step the instruments forward, doing any life cycle events along the way, and tell me, essentially give me a distribution of the paths. So here it popped up a little chart here which says, here is a bunch of mark-to-market percentiles and cash balance percentiles. And so this thing here is 5%. So in 5% of the cases, my mark-to-markets are at this level. And this is, for example, the 25% case, this is the 50% case, 75%, 100%, 95%, sorry. And as you can see, there's sort of a nice analogy between the mark-to-markets and the cash. After cash settles, it kind of goes to zero. So you can see here, for example, cash, like something settled here, turned into cash. And actually this interesting thing here where you see this thing moving around, this is because we have some euro cash. We're not doing rolls in the simulation. So you can see it still has some mark-to-market effect. But the interesting thing, if I look at this here, is, in 5% of the cases, I have approximately a 5 million downside. And I might want to say, well, in this environment, I do not want that. I want to try to limit my downside. So I can go back in here and say, well, actually, there's actually a lot more detail behind underneath the covers. But I'm just going to, here, my estimation was, this is a rough thing. This is 5 December 2019, from November 5th. And actually, this happens to correspond almost exactly to this expiry, right? So I'm guessing this is FX forward risk. If I go rerun this thing, let me just go underneath the covers a bit here. You can see when I ran that, it actually went and scheduled out a simulation, moving all the market data forward, evolving all the instruments, and ran this on this distributed compute infrastructure that we have. And you can see I have a whole bunch of engines that are spun up, and these are running essentially containers. And each of the containers has exactly the same environment that I have in my local session. I think that's always the tricky thing about building all this infrastructure. It's easy to get it to work, on your desktop but if you want to scale this thing out, you want to spin up compute, you want to send the code that you've written, like I made a local change here and it just automatically replicated it over to all those containers. Anyway, I got back the numbers, so let's go look at those numbers. And see, this looks actually much, much nicer, right? I basically left to 1.7 or I've also, of course, limited my downside. That might be a reasonable trade-off. And what's also interesting about spreadsheet, which had a bunch of these. So here you can see I have a fairly mixed set of positions. I can describe these things as FX options or interest rate swaps. I can, for example, compute like a 10-year swap at par. If I go bump this thing, it'll actually just recompute and calculate the fixed rate from the par rate for me. There we go. And I can just retype stuff. For example, this is just recalculating this in the new spreadsheet, but there's no spreadsheet. It's sending all the backend requests to Beacon to compute things. So your Excel session, your development environment, your trade blotter, your quote tool, completely the same analytics and completely the same data. Back to you, Anya, for the next scenario.
Thank you, Kirat. So for the second scenario, Kirat mentioned just now the infrastructure services that we're running underneath the hood to be able to do some of the scenario analysis. So we're going to explore that a little bit deeper. So for example, I am a chief technology officer. My organization is starting to use the cloud. And what I'd like to understand is how I can use Beacon to monitor my infrastructure, to give access to business users on demand, and make some configuration changes. For example, if I want to use GPUs. So Kirat, I'll turn it over to you for the next part of the demo. If you don't mind just zooming in a bit on your screen so it looks a little bit bigger and just speaking up a bit. Thank you.
Yeah, absolutely. Sorry about that. So I expanded my screen. I did have a note to myself that I was going to do that, and I didn't. So we got a little bit of a preview here. So when we were running these MapReduce style simulation compute, you could see here's my grid compute scheduler. So what we found, I think, with I was joking the other day that like when we were setting up infrastructure at banks, we would go fill out a whole bunch of purchase orders and we'd ask for more compute. It would kind of show up in 3 to 6 months in the data center, and then it would take us like 6 weeks to configure it. And now if you look at it with the cloud, you can pretty much spin up that same computer in 30 seconds. But you still need to configure it. You still need to make sure that it has the right patches, it has the right OS version that you need, the right containers, the software, etc. And that's a lot of what Beacon enables for you. And we sort of put all these components together. So in this case, I didn't actually know I was running on Elastic Compute. You can see here, we have 40 engines that are idle. 19 of them are disabled because we don't need that compute, and they're going to get shut down in the next 5-10 minutes if no one uses them. You can create different pools of compute with different CPU ratios and priorities. Again, we can show you how to do that. We also run VS Code, actually manage apps inside Beacon. And the reason all this is kind of neat is because if you have stuff sitting on your desktop, especially in an environment like this too, it's hard to configure, it's hard to maintain, it's hard to update. Whereas if you do this through the cloud, through Chrome, as long as I set up my 2-factor auth to get in, I can have access to essentially all my computer infrastructure on tap through a Chrome browser. And so here actually I'm running VS Code, and you can see I have exactly the same set of changes that I've made as I have in this other IDE that I have. I can run applications through here. Oops, sorry, lost my headset. And so I think what we found with managing infrastructure as well is you can spin all this stuff up on the cloud, but then you want to maintain it. Are you getting the right CPU utilization? So how do we do that here? Well, we expose all the monitoring infrastructure to you. So I can go look, for example, actually, let me go back here, apologies, to this compute dashboard. And I'm going to actually just ask for more compute. So I'll say, actually, I want 5 more machines. I'll pay on-demand price. I can actually pick any instance type I like. And I just go say add engines. And this will go place a bid on AWS for spots. In this case, I asked for C5 large. That's the default. It's going to bid 8.5 cents. And when this request is satisfied, it'll automatically spin up those machines and they'll become available for me to use for compute. I didn't actually need them, as you can see. Everything is idle, but actually, sorry, I have too many things open. So yes, for monitoring dashboard, that's showing for all the you have in this compute pool, what's their utilization. So you can see yellow line, and then covering its histogram essentially is allocated compute. But we are actually relatively quite efficient. Right? So there's no compute until there's demand. We spin up compute, sort of steps up until all the demand is satisfied. There's a soft cap here just for you to limit your AWS bills. And then when everything is idle, it basically just shuts. And this would be across thousands of cores. And actually, recently, one of our bank clients, has since they have the cloud, they've gone from 800 cores to 2,000 cores. It's kind of interesting, helping them deal with some of the scaling challenges there. And here you can see down here, we can see all the events that caused all these things to happen. So sorry, I'm just scrolling too much here. So you can see here, this was me requesting some instances. Here's a bunch of our test jobs going and spinning up compute because it had demand. And of course, I can go look at this over a much longer period as well. I can see, what happened over the last 7 days. And that's again interesting for you to see, how you're using your infrastructure. But that's not all. So if you go look, this is sort of a really interesting thing too, because we're running a whole bunch of compute all the time, batch jobs, ETL jobs, and things like this. So this is a real-time view of all my jobs that are running in this environment and what they're doing. So you can see, like I'm looking at this 3-hour window here, CPU usage by all my jobs across all my infrastructure. And, actually one of these things is generating a nice sawtooth waveform. So this thing, I can go and see what is this. Well, it's some feed job that's doing something. And it's kind of neat here. I can actually correlate CPU and network. So why is it doing this? It's probably because it's doing some compute, generating some network traffic, and then stopping. And I can see down here, network traffic. And, you can see these things are lining up. And, this is about right. The peaks of the CPU as the peak of CPU drops off, network utilization increases. So I could then go look at this job. This is in bold right now to see, why is it behaving like that? And then, for example, here's something that was, quite expensive over this time. It sort of rolled off on this list. And you can do the same thing for memory and all. So this is basically real-time monitoring on all your infrastructure across all these elastic nodes that have spun up. We can also do this for each of the machines themselves. So, if I go look at some of my elastic compute, here's kind of an interesting thing, which is one of our elastic compute agents. And you can see it's not on all the time. And if I go look at this over the last 2 days, when there's demand, it spins up. And so all these graphs look pretty much like sort of nice, happy, well-utilized elastic compute. Busy, 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 tails off, shuts down. You can see that for CPU, memory, network statistics as well. So, I think there's just a lot of moving pieces here, and I think integrating them together to give you a sort of holistic view of your infrastructure is really, I think, is what we've spent a lot of effort on. And just finally, before we go into the next scenario, I'm sorry, I'm going to run out of time otherwise. We also have started exposing all the configuration information to our clients. And this is multi-cloud. So we have a little abstraction that defines your entire infrastructure. So this is Acme, which is one of our test environments. You can see here, if you have the correct role, you can just change the code in this IDE here, push it out, and then apply the changes to your infrastructure, sort of all infrastructure as code. And we can do anything here. So here, for example, this is an EC2 instance. If this was Azure, this would just say AZ for Azure. We can define storage. So some of these things are deleted on termination. This is a swap volume. And you can see, I can also configure it so when the machine comes up, it'll automatically mark this as swap. The persistent volume, and in this case, actually, we're using an LVM volume manager. We can even define the size of these volumes and grow them essentially on demand. This machine runs Redis, so we can also go tweak all the current parameters for Redis to make it optimal. So, for example, I set TCP buffers and backlogs because, that improves Redis performance. We talked a little bit about these compute pools that we had. And these are sort of configured very much the same way. So we construct these sort of template machines. So, for example, when I ask for Spot instances, I'm actually constructing one of these templates. And you can configure on these machines what optional packages get installed, what services you would run, etc. And also instance types. So if I wanted a machine with, better CPU memory ratio, I could just change it to this, save this, commit it, push it out, and that would just spin up, that would just change the rest of the machine structure, add a new pool. I could even switch this to GPUs. Actually, I forget what they call GPU instances, but if I just look that up from AWS, I think they're P something or the others. Just changing that is still validated if I run it. Will just allow you to spin up GPUs. And I think that's really the interesting thing about having all this software-defined infrastructure on the cloud. In the old days, if you try to get a GPU, super hard to get it into a data center, worry about thermal envelopes and power. And only a few people had access to them. With this infrastructure, you can basically create a pool that has GPUs. Anyone who has access to Beacon then can just schedule stuff onto that, whether it's VS Code sessions. So, one of our clients actually wants to run a bunch of VS Code sessions or notebooks, etc., on VS Code. And it's as simple as defining a that runs GPUs, these apps that are running on that pool in the market. So Anya, back to you.
Thank you. So now that we've seen one business use case and we've taken a peek under the hood of the underlying infrastructure, we'll tie it all together with the final scenario, which is I'm the head of trading. I'd like to create a new risk report, but one thing that we see a lot with our clients is that the research environment where analytics are developed can be quite disconnected from the production environment where the trading and risk decisions are actually made. So the scenario here is, how can Beacon help connect these two? And we're going to take a look at a risk report as an example of this. Kat, go ahead.
Cool, thanks much, Anya. So, just going back to some of the topics that we've already covered. As we were talking earlier, we have all these applications, which looks, probably like other trading system applications. Here's like an interest rate swap. I can, look at my curves here. I can go run reports. So say I'm an end user who's either a trader or a salesperson. I can go and see, some bucketed row report for this thing. But if I was a developer or a quant and I was building this report, I actually want to build it in my development environment. And so what does that experience look like? So as we saw, we have a bunch of IDEs. So we have, for example, VS Code sessions in here. We have sort of a slightly simpler IDE as well. But you might, since Beacon is really a container orchestration tool, you might actually want to run some other things like Jupyter notebooks and things like this, which are easier to just look at data and visualize it. And it's pretty much as simple as running it through these app tiles over here. So in this case, I have, so I've saved a few notebooks here. So I'm just going to go look at some of these. And you can see actually these notebooks have access to pretty much exactly the same data and exactly the same APIs and analytics that I have in all my apps. So say I wanted to, for example, construct some test book here. I have access to all the book and deal code. I can construct a bunch of swaps. And this is sort of related to the simulation that we did, where we want to show the positions of a book and propose lifecycle events and evolve it forward in time. Sorry, not a very pretty display over here, but you can see this is running this thing through a whole bunch of lifecycle events. So you start out with some interest rate swap. First life cycle event, it spins off some cash. I went out of the old swap and into the new swap. And then I keep accumulating cash essentially as the payments go through. And in the end, I'm left with simply some cash and the last zero coupon bond. And then I can also do things like, this looks a little bit similar to my other portfolio that I've been looking at, where I can just construct a little book in memory, run an interest rate delta report, run a multi-FX report, which actually goes and bumps the constraints, generate a data frame, pop it out, and iterate on it with whoever my end user is. And again, the neat thing is it's exactly the same set of code, exactly the same set of data. I have access essentially in read-only mode in my development environment to all my production trades and positions. And I can also do things like go run compute on WIMP, which is our grid compute scheduler. So in a notebook here, for example, I'm running like a little trading strategy simulator. I have some remote function. I give it a list of dates. I give it a date, and then I can very simply do a map reduce to map this function across a range of arguments. And if I go rerun this thing here, you'll see it will just pop up on my grid compute infrastructure. And here I am, running 33 tasks. There's a whole bunch of other stuff running, but it's a priority-based scheduler, so it's not going to starve me. I can even go and actually bump my priority. Sorry, wrong button, set priority. Since I have permission to do it, you can control these things. So you can see now I'm going to get 10 times as much compute as all the other jobs by weighted priority, essentially. Again, just to reiterate what we did here, so we wrote some code in a notebook, didn't have to deploy it anywhere. Simply ran a map reduce. We streamed the code on the fly over to these remote containers that we've spun up. These could be spot engines that spun up like literally 30 seconds ago, and it just works. And when it finishes, it will go plot me. I think it just did. It'll go plot me this thing, which is the results of my simulation. So apologies, I think we went a bit over, but I'll go back to Anya for the wrap up there.
Thank you, Kirat. So I think that was a great way to end the demo portion. And in the last couple of minutes, we'll go over a few frequently asked questions. If you have a question that we don't get to today, you've got the GoToWebinar control panel on your screen. Please submit the question there. We'll be sure to come back to you. But Kirat, thank you very much for that demo. I think that was a really good example of how business users can interact with the platform through a GUI. You can interact with it if you're more technical at the notebook level. You can use the IDE at the even more technical developer level, and you've got full transparency and control into everything from the source code to the infrastructure tools. So in the last couple of minutes here, let's go over a few of the most common questions that we get. So one, it's the why Beacon question. Why use Beacon rather than using open source technologies or building everything in-house, which Kirat, you've done multiple times?
Yeah, great question. And, I think there's a lot of open source that underpins Beacon. And what we really found is it's about curation and also putting this together in a way that everyone isn't, essentially gluing things together in slightly different ways. And, when I started in the late 90s at a bank, there wasn't any open source tools really that used, like asynchronous programming really wasn't even there. Everyone built their own compute schedulers. Everyone built their own databases, in fact. And now I think really with cloud infrastructure, it's about creating the framework around it so that you can, like we demonstrated, spin up containers, write applications without and having to be up to date with all the other APIs in the ecosystem around you evolve. So just as an example, recently, we just upgraded all our clients from Python 3.4 to 3.6. I think pretty much seamlessly, actually not recently, about 6 months ago. We just did a Pandas upgrade for all our clients. We enabled staging environments for them so that they could run them both sort of in parallel. We've also done things like, for example, Beacon manages all the patch levels of all the OSs and all as well. Modular finding rebuild windows, which is it's fairly easy for us to just go and upgrade them all. So I think really it's about that sort of level of integration and having a curated set of tools, and of course we've built a lot of other infrastructure on top of it.
Thank you. I think that's a good segue to the next question, which is, how does Beacon interact with an existing tech stack, right? We're not always walking into a green field. People probably already have some combination of in-house tools, open source tools, on-prem, cloud. How does Beacon interact with that existing stack?
Great question. And, I think, we really think that, as we said earlier, that Beacon shouldn't be a big bang. So we try very hard to be very open to integrate. Of course, all the source code of Beacon itself is open. And typically, the first thing we do with our clients is help integrate their internal quant libraries, whether they're banks or asset managers or insurance companies. Typically, it takes us like a couple of weeks at most to help with the initial integration. We can set up CI/CD builds. They can then actually use Beacon to test new versions of their libraries with their applications. It creates a testing environment, and some of our clients actually have found it's easier to migrate to new versions of vendor systems as well, because you can use Beacon as that sort of staging test environment, because we have very robust integration tests and regression testing frameworks. And of course, we integrate with on-prem data centers. It's always connected. The cloud is connected into your on-prem data center. You get access to all your existing databases, modular the latency of the connections. We can trades and purchases, external vendors, internal vendors, plug them into Beacon, and then Beacon becomes your place where you have a common data model and common analytics without having to think about where the data is coming from. Back to the picture we saw in the beginning.
Thank you. So last question, the current environment, of course, is challenging for a lot of us. We're working from home. There's been a lot of market volatility recently. How has Beacon adapted to the current environment, and how have we helped our clients adapt?
Yeah, it's been a super challenging environment, as you can imagine. I think we're all working from home, and actually very fortunate that we are able to do that. I have so much respect for folks at grocery stores and hospitals who are actually making that possible for all of us. So we're very lucky. We can just be too much change for us. Modern children jumping in every once in a while. But I think what's been interesting for us is us moving to work from home was essentially a non-issue. All our infrastructure is on the cloud. We have VPN set up to access it, and it's very, very easy. And I think really what is interesting in this time is that you want elasticity on your infrastructure, because you don't really know what your sort of business demand is going to be. And the cloud is a great way to enable that. We support both Azure and AWS as well. And I think longer term, you actually want DR capability between two cloud providers, which also Beacon can enable for you. The Beacon APIs work kind of just the same across both cloud providers. You're also going to do GCP later this year. And I think it's been exciting for us, for our clients. A couple of our clients essentially smaller hedge funds transition to work from home with zero issues. And I think the fact that all their infrastructure is just running in the cloud, they have no desktops to worry about. It's great to be able to enable that. And for some of our other big clients as well, as we mentioned earlier too, just increasing compute without having to worry about staging centers, running one-off scenarios, just adding 1,000 cores, has been basically fairly straightforward, something like Beacon. So I think as this evolves as well, people have essentially executed the DR plans, and there's really no DR for the DR. It's like, if you have limited on-prem infrastructure access centers, I think really the only way to mitigate some of that is being able to just use direct cloud access using VPN to the cloud provider rather than through your on-prem data center. So I think that's where we see some of that evolving.
Thank you. So again, everybody, really appreciate you taking the time to join us today. If you have questions, you can submit them through the webinar or just shoot us an email, info@beacon.io. I know some of you have reached out, you were having trouble with the audio. We'd love to give you a dedicated demo or presentation, so please reach out if you have any questions or you'd like to learn more about Beacon. And again, stay healthy, everybody. We hope that we'll have the opportunity to meet you in person very soon. Thank you all for joining. Bye-bye.
Thank you. Bye.